Assalamualaikum everyone. So today me and my friends will present about the photoelectrochemistry for our SCL. So first thing first, let me introduce myself. My name is Maisara binti Asmaon and my metric number is 192790. So let's start with the theory of photoelectrochemistry. Photoelectrochemistry is a study of physical chemistry which is concerned with the interactions of light with electrochemical systems. It can convert electromagnetic radiations, for example like the sunlight, into the electrical power or into something which can itself be easily used to produce electrical power. And there is a few examples. One that I include here is hydrogen can be burned to create electrical power. Example of photoelectrochemistry cells. The first one is the photovoltaic cells and the second one is the photoelectric cells. For photovoltaic cell, it is actually creations of voltage or electrical current in material upon exposure to lights, and the electrons can absorb the energy and become excited, and then when the electron is excited, electron will move to the conduction band to become free. While for the photoelectric cells, it is actually the emissions of electron from a solid to liquid or gas upon exposure to light. So, electrons are ejected when excess energy is absorbed. As the result, the photon energy will not be able to escape if the photon energy was too low. I show you the difference between photovoltaic effect and also the photoelectric effect. At the left of the screens, there is a photoelectric effect. How we know that this is the photoelectric effect? The emissions of electron will occur when a surface is exposed to photons of sufficient energy. When we have a sufficient energy, electrons are ejected from the surface. At the right on the screen, this is a photovoltaic effect example. Photovoltaic effect will use sun as the energy, and then when there is a potential difference at the junction between the two dissimilar metals, it will create the EMF. Next, we will proceed to the photoelectrochemical setup from my friends.
Hi, I'm Aisha. I'm going to present the photoelectrochemical setup. Photoelectrochemical characterizations can be conducted in a single compartment cell with a Pyrex window, which is a transparent window in order to allow light to penetrate the cell and be absorbed by the electrodes, because we know that PEC cells extract electrical energy from light. PEC cell also has a 3-electrode configuration system where the prepared samples are the working electrodes, a platinum wire is the counter electrode, and silver chloride in saturated KCl is a reference electrode. Well, there are many other examples of counter electrode and reference electrode, but platinum wire and silver chloride are the common ones we use in the lab. The electrodes are dipped in the aqueous electrolyte, for example like sodium hydroxide, potassium chloride, and sodium sulfate aqueous solution. A low-power UV LED can be used as a light source. The electrodes must be in electrical contact, so a conductive wire is needed to connect the electrodes. Potentiostat used to measure the current density and to evaluate the electrical properties of the PEC cells.
Thank you, Aisha. Assalamualaikum and hi, my name is Ani Zulaika. I will proceed this presentation, but still in the same topic but different situation. So let's say if we have situation where the two electrode, which are the counter electrode and the working electrode, are too close to each other. So what will happen? What will the problem and what we will gonna do to face the problem? So when the two electrode are too close, there is a possibility that the gas will evolve at the one surface in which it will may contaminate or back react with the reactant or intermediate of the other electrode. So to avoid this problem from happen, we introduce the cell with a membrane that will place in the between of the working electrode and the counter electrode. So what is the function of this membrane? This membrane, as I said before, it will prevent the crossover of the gases product, so it will avoid the hydrogen gas and the oxygen gas mixed together, and secondly, it will be directly allow hydrogen and oxygen to be evolved in their own separate container. So in resulting, after we place the membrane at the cell, we will have two different circulation, which is one circulation at the working electrode and the other circulation in the counter electrode. The magnetic stereo also will have two at the different position, which is one position at the working electrode and the other one is at the counter electrode. So, for your information, the function of this magnetic stereo is to maintain the electrolyte concentration and to minimize the pH gradient. That's all from me. I will pass this presentation to my group member.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nalini Binti Zali. My matrix number is 192357. Now I will continue by explaining about the photocurrent. These are the important terms that must be taken into account for you to understand more about the photocurrent. Where does the terms of photocurrent comes from? First, you have to know what is photoelectric effect. Photoelectric effect is defined as a phenomenon when a metal surface is exposed to a monochromatic electromagnetic wave of sufficiently short wavelength. The incident radiation is absorbed and the exposed surface emits electrons. The emitted electrons that are produced in this process, we call it as photoelectrons. The experimental setup to study photoelectric effect is shown in this figure. The target material serves as an anode, which becomes the emitter of the photoelectrons when it is struck by the incident light. This electrode, also known as photoelectrons. The photoelectrons are collected in the cathode. These two electrodes are kept in an evacuated glass tube so that the photoelectrons do not lose their kinetic energy on collisions with the air molecules in the space between the anode and the cathode. When the target material is not exposed to a radiation, no current is registered in this circuit. But when the target material is connected to a negative terminal of a battery and exposed to radiation, there is a current registered in this circuit. The current, we call it as photocurrent. As you can see here in this circuit, there are voltmeter and ammeter. The function of voltmeter is to measure the potential difference between anode and cathode. The function of ammeter is to measure the photocurrent produced in the circuit. Now I want you to imagine what happens if we connect the target material to the positive terminal instead of negative terminal. Okay, if we connect the target material to the positive terminal of a battery, the photoelectrons emitted in the process are attracted to the target material. So the current produced in this circuit will be decreased. If we keep increasing the positive potential of the target material, the current will continue to decrease, and at a fixed potential, the current will become zero. This potential, we call it as stopping potential. Why you need to know about the stopping potential? It is because the stopping potential gives you information about the threshold frequency. The stopping potential does not depend on the intensity of the light, but it depends on the frequency of the incident light. From this, we can observe that at a fixed value of the frequency of the incident light, no electrons emit from the metal. For every metal, there is a minimum frequency of radiation that will produce a photoelectric effect. This frequency, we call it as threshold frequency, also known as cut-off frequency. This will be further explained. You can see why threshold frequency related to photocurrent in the section in factors that affect the production of photocurrent. There are 4 factors that affect the production of photocurrent. The first one is the intensity of light. The second one is the frequency of light. The third one is the number of photoelectrons. And the last one is the kinetic energy of photoelectrons. These factors will be further explained by my friend Alia. Thank you.
Hi everyone, so I will continue the presentation with the factors that affect the production of photocurrent. The photoelectric current is produced as a result of photoelectric effect. Therefore, understanding the factors which influence the photoelectric effect is very important. Like Dini have said before, there are 4 main factors that may have a direct impact on the photoelectric effects, which are the intensity of light, frequency of light, the number of photoelectrons, and lastly is the kinetic energy of the photoelectrons. For the intensity of light, if a high intense energy of frequency equal or greater than the threshold frequency falls on the surface of matter, the photoelectric effect is caused. The emission of electrons does not depend upon the intensity of light unless the frequency of light is greater than the threshold frequency. For the second factor, which is the frequency of light, if a beam of light with frequency equal or greater than the threshold frequency strikes the surface of matter, the photoelectric effect is produced. If frequency is less than the threshold frequency, then the photoelectric effect cannot be seen. The threshold frequency varies from matter to matter. The third factor is the number of photoelectrons. The increase in intensity of light increases the number of photoelectrons, provided the frequency is greater than the threshold frequency. In short, we can say that the number of electrons increases the photoelectric current. Lastly is the kinetic energy of the photoelectrons. The kinetic energy of the photoelectron increases when light of high energy falls on the surface of matter. When energy of light is equal to threshold energy, then electrons are emitted from the surface, whereas when energy is greater than threshold energy, then photoelectric current is produced. Like I said before, the threshold frequency is not same for all kind of matters and it varies from matter to matter. So we can say that types of metal also is one of the factors that can affect the production of photocurrent because of the different values of cut-off frequency. So based on this table, this proves that different materials have different values of cut-off frequency. Thank you.
Assalamualaikum everyone. My name is Nur Aiza binti Baru Hisham. So today I'm going to explain about photovoltaic cell. So what is photovoltaic cell? It is a system that converts sunlight directly into electricity using semiconductor cell. It means that it will generate electricity when exposed to photon or particles of light. This conversion of electricity is also called photovoltaic effect. So photovoltaic cell require 3 basic conditions. The first one is the absorption of light, generating either electron hole pair or exciton. Second is separation of charge carrier of opposite type. This means there is separation between electrons and photons. The third one is the separate extraction of those carrier to an external surface. So this will generate electricity. Next is how photovoltaic cell working. So first, when the sunlight hit the cell, the photons in light excite some of the electron in the semiconductor to become electron holes pair. So this means that when the photon is struck to a semiconductor material such as silicon, they release the electron from its atom, leaving behind a vacant space. So the vacant space is called the electron hole pair. So the electrons move looking for another hole to fill. So the next one is the discharge separation. Set up a voltage difference between either end of the cell. Hence, the electron move to the negative electrode while the holes move to the positive electrode. So, this creates the separation of charge between positive and negative. The third one is the conducting wire connects the negative electrode, the loads, and the positive electrode in the series to form circuits. So, this will generate electricity. In this photovoltaic cell, semiconductor material are doped to form PN structure as an internet field. The N type is negative silicon, which has tendency to donate electron, while the P type is the positive silicon, which have tendency to accept electrons. So as you guys can see here, this is some example of the photovoltaic cell. This arrow means there are some photon that is reflected and lost due to the surface reflections. Due to this condition, usually in photovoltaic cell, they will add anti-reflective coating to minimize the loss of the photons. So, when sunlight hits the photons, it will photon will excite some of the electron, as I said earlier, in the semiconductor. So it will become electron hole pair or negative positive pair. So since there is an internal electric field, it will create separation of charge. The electron will move to the negative electrodes, while the hole will move to the positive electrode. This will create the separation of charge between the positive and the negative. There is also a conducting wire connected the negative electrodes and the positive electrode and the loads. The end of the wire connect to the one of the negative electrode, while the other end of the wire connect to the other end of the positive electrodes. So this can create an external circuit. Usually this is how the photovoltaic cell works. Next, in the photovoltaic cell, there is also the potential barrier. The potential barrier is set up by the opposite electric charge facing one another on either side of a dividing line. Potential barriers separate the electrons generated by light and hole, causing the formation of a voltage difference between either end of the cell. So this can create electric current in the external circuit. The barrier consists of two types of silicon crystal. The first one is negative carrier dopant, and the second one is the positive carrier dopant. The negative carrier dopant also acts as a donor, while the positive carrier dopant also acts as a receptor. As you guys can see here, this is some example of the silicon crystal lattice arrangement. In this picture, as you guys can see, this is the arrangement of the semiconductor silicon. So next I will continue about the negative carrier dopants, which also act as a donor. An impurity is introduced in the pure silicon crystal by substituting a silicon atom with a phosphorus. Phosphorus have 5 valence electrons. The impurity atom can occupy the same position as the normal silicon atom. This means that this is the silicon atom, so impurity can occupy here the normal silicon atom position by supplying an electron for each of the silicon 4 bonds. As you guys can see here, between each, this is the silicon, so 1, 2, 3, 4 electrons, and they shed another 4 electrons by the other silicon. So 2 silicon shed 4 electrons, so they will have 8 electrons together. But when a silicon atom is substituted with phosphorus have 5 electrons. So it will have one extra valence electrons. There would no one electron with bond to share. This unbound electron is free, as there is no hole for the electron to fill, so it can move around freely. A silicon crystal with numerous substituted phosphorus atoms would have many free electrons, which means if this many silicon is substituted with phosphorus, you would have many free electrons, because of each phosphorus has one extra electrons. So a silicon crystal with however, n-type silicon alone cannot form the barrier, because usually if the semiconductor to work, we must have n-type silicon and p-type silicon. If we don't have p-type silicon, there will no separation of charge.
Okay, so I will continue the presentation with the positive carrier dopant. So basically, p-type silicon is just the opposite of n-type. So instead of using impurity with one extra valence electron, they use atom or impurity with one electron less, such as boron. And this boron is then substituted in the silicon crystal layer. So one of the bonds with the silicon would be missing an electron. This will form a hole that is also free to move about in the crystal. So in this way, a silicon crystal doped with many such boron atoms has many holes that act as if they were free positive charges moving throughout the crystal lattice. Okay, so this is the n-type silicon. If you can see here, there is an extra unbound electron that free to move around in the crystal lattice. So in p-type silicon, there is a missing electron that forms a hole here, and this hole is also can move relatively free in the crystal lattice. Okay, next we proceed to the junction. When the n-type and p-type materials are in contact, the electrons from n-type material will jump to the p-type materials to fill the hole. So this causes an immediate imbalance of charge, which are more negative charges along the p-type side and more positive charges along the n-type side. So this creates a fixed potential barrier at the junction, with the n-type side adjacent to the junction being positively charged and the p-type side adjacent to the junction being negatively charged. However, there are still a few free electrons in the n-type materials that are unable to cross the potential barrier to fill the holes in the p-type material. Okay, so if you can see here, this is the n side and this is the p side. So it shows in the n side that there are free electrons and there are free holes in the p side. So when the p and n are joined together, electrons will move from the n side to fill the holes on the p sides. So the positive charge begins to build on the n side of the junction because of the loss of electrons. Since the electrons will move from this side to this side, so it will produce, or it will form positive charge that builds on the n sides. So the negative charge begins to build on the p side as electrons fill the bond vacancies or holes. Okay, so near the junction, most of the free electrons on the n side have moved to the p side, creating a large positive charge at the junction. Large negative charge is created at the junction because of the transfer of electrons to the p side to fill holes. So when the positive charge builds on the n side and negative charge builds on the p side, so this is what we call junction and also the potential barrier. So the extra electrons that is on the n side will no longer be able to cross the junction to the p side. Okay, so basically there are excess of electrons on the n side and excess of holes on the p side. Okay, next, how the electric current flow. So when the sunlight strikes, the energy is fairly enough to free the electrons from a bond in the silicon crystal, causing more free electrons and hole on the n-type material. So the same thing is happening on the p-type material, causing more free holes to form. So because of the illumination and also the charge separation causes the presence of uncombined excess negative charges on the n-type side and excess holes on the p-type side, a charge imbalance exists in the cell. So basically when the sunlight strikes, so it will produce more electrons on the n side and more holes on the p sides. So this will cause a charge imbalance. Okay, so if we connect the n-type side to the p-type side of the cell by the means of an external electric circuit, for example like wire, so the current will flow through the circuit because this reduces the light induced charge imbalance in the cell. So to balance the cell back again, so you connect the external electric circuit from the n-type to p-type, and the electrons from the n-type will move to the p-type side through the external circuit. So that is basically how the electric current flow in PV cells. Okay, so that's all from us. Thank you for listening.